Good morning, everybody from Vancouver, Canada. I'm Branko Deljanin and your host for the webinar 10 from CVD Factory to Market. We have a very special guest today, and I will say good morning to Dusan Simic, our moderator for today, and Ashit Gandhi from US Diamond Technology. How are you?
Thank you. Good. Welcome.
Very good. And good evening. It's evening in Mumbai, India. We have Darshan Shah from DM Gems Group and Shriyan Shah from Flawless Allure Grow Diamonds. Good evening and thank you for coming.
Good evening. Good evening. Thank you.
Hello, guys.
Yes, it's very special for us to do these webinars around our book, Laboratory Grown Diamonds. You can see it on the left, and we're very proud to say in 4 months since we published October 15, we sold 1,000 books. We broke this record 1,000 just a few days ago. And for those who didn't get it, you can see on the bottom left our website, brankogems.com. Under books, you can order and get 10% discount. So book is quite big, 188 pages. We try to cover history, background, technology, identification is a big part, and certification and tracking. What you should take out of this book, if you are a wholesaler, appraiser, retailer, or gemologist or manufacturer, it's that you should read summary what wholesaler, appraiser, or retailer could do with the standard instruments. It's a 2-page summary, and then what you can do with the standard instruments like a loop microscope, cross-polarized filters, and fluorescence. This is every jeweler should have these minimum instruments. Of course, there's much more in other chapters. So we are very thankful to a very special group of people who help us. First one is Boris Figelson, a researcher who from Naval Research Laboratory. He did on HPHT growing of diamonds process. Sherry Woodring from GK Laboratory in New York, our colleague. We did first version with her in 2004, with Dushan 2007, and this is the last one, hopefully to be more. Malay Hirani, another good engineer from India, did on CVD grow diamonds, and Frank Ripka from Godanca help us with the chapter on memorial diamonds. Antoinette Matlins, Richard Drucker, and Stuart Robertson from USA did the review of the book, and Alberto Scarani from Maggi Labs Italy, technical review. And of course, our trade friends and supporters, Anilesh Resh from Nice Diamond, Tom Chatham from Chatham Created, and we had a great design from Godwin and Mubdan Gonzalez, and our friend Nesha Popovic was responsible for marketing and promoting these webinars. Our sponsors were NCJV Australia. Kim Hughes ordered a lot of books for all their members, and Gail Brett Levin for NAJA appraisers in USA. And in UK, we have a JVA, Shirley Mitchell, responsible for distribution in England. So I'll just go fast through a few webinars. You can see, you can watch them on YouTube channel, Branko Gems and AG&J. This is first one on technical part, how to grow diamonds. It's a like 15-page article in our book. Second one was more trade-oriented from one of the first producers and the marketer of diamonds, Chatham. Tom Chatham was talking about his past, present, and future, and of course, our industry. Then we had very interesting, controversial chapter. We repeated 2 times this lecture. We didn't record it. This is the only one is not recorded. On memorial diamonds by Frank Ripka. You can read about this in the book as well. I already mentioned Boris Figelson, how to grow diamonds by HPHT process. And you can listen this on YouTube. Our colleague Sherry Woodring was talking about inclusions in CVD and HPHT grown diamonds, how to appraise, what is the value, what is the problems on identification. And Sherry is also on YouTube. My colleague Dusan Simic, we started to work together 20 years ago in New York in a previous laboratory, GL USA, and other. We keep publishing books together and do interesting research, over 100 papers together. He was talking about how to use cross-polarized filters, like you see a picture on the left, to see if diamond is natural or HPHT grown or CVD grown, or how to track them in a parcels or mounted with a special technology and patent that he was talking about. I was talking more about fluorescence as one technique to screen diamonds, not always final, and how to use other advanced instruments, infrared visible fluorescence spectroscopy in a laboratory to finally ID them So it's a final answer. So all these are on our YouTube channels. And then we had a very visited and very interesting roundtable with the jewelry magazines. Albert Robinson from New Jewelry in Israel and Middle East was a moderator. Rob Bates from Jessica Magazine was panelist. Dan Scott from Lab Grown Diamond Magazine, Mark Kulinan from Kulina Diamonds, and Tanya Nizgrevsky from Virtual Diamond Boutique. Basically, can these diamonds coexist? And we concluded that they are coexisting, and they're selling many retailers selling now both natural and laboratory grown diamonds. Dusan Simic from New York will take over now as a moderator. And Dusan, please introduce our first panelist, Ashit Gandhi from US Diamond Technology.
Okay, thank you, Branko. Of course, you know. And good morning, good day, good evening to our panelists and all our guests and attendees. You know, welcome to all of you, and thank you for being with us at this webinar number 10. The title today is CVD Diamonds from Factory to Market, and our three panelists will present in form of short video or PowerPoints and talk about CVD diamond growth, polishing of CVD rough diamonds, and marketing of polished CVD diamonds. First, I have to say that Branko and I are very grateful that our panelists opened the doors of their factories and businesses in order to show how this part of the diamond industry really looks. I think this is the first time that someone from industry positively answered to such a specific request. Thank you again to Ashit, Darshan, and Shreyans. Of course, dear guests, after the presentation, our panelists will be ready and available to answer all your questions. Let us start. Ashit Gandhi is CEO and CTO of US Diamond Technology, a company from New Jersey, USA. He is the inventor and main engineer in his company. Ashit, please show and tell us what your company is.
Hey,
welcome.
Thank you, Dusan. Hello, everyone.
Hello.
We here at US Diamond Technologies design and build innovative CVD reactors in New Jersey, USA. And here in my presentation, I'll give you a quick snapshot of our manufacturing and testing facility, which is pretty much give you an idea of what a facility that has CVD reactors looks like, and a brief video of how growth is done. So let's get started. Here's the lab, and I'll walk you through different various components of the system. Of course, the first one is the reactor itself. In the facility, along with the reactor, you have the closed loop chiller required to keep the machine cool. The vacuum pump to maintain vacuum pressure and gas pressure in the system. Of course, the gases, which are your ingredients, they can come in a form of cylinders or a hydrogen generator, especially for high-use hydrogen gases, a lot more safer. And then, of course, the connections and wiring, gas pipes, and everything else that goes behind the machine. A typical reactor on the front consists of the vacuum chamber and the HMI, human machine interface, or a computer that controls the machine. On the back side, we have the power connection, the gases that are coming in to the machine, and connection for water, again, coming from the chiller. That's our manufacturing assembly line in New Jersey, building several reactors over here. And that's our test facility. So before the machines are packaged and shipped to our customers worldwide, we actually test these machines over here. And the video that follows is really a snapshot of one of the growth cycles that we do during testing. The first step for a growth process, of course, is seed preparation. slicing it to uniform size and thicknesses, and making sure they're good clarity and cleaned in acid and alcohol. This is showing a typical layout of the seeds on the moly discs as the growth starts. And the first step is to start the reactor. Get the plasma, get the vacuum first, get the plasma, and so on. So here's a short video showing a few seeds being loaded onto the machine. They've been pre-cleaned, the chamber's been pre-cleaned, and the moly discs have been pre-cleaned. Load your seeds in your determined formation, lock the chamber, and turn the process on. Pretty much, the process goes automated from here, creating the right conditions, right vacuum pressure of gases required to generate the plasma. And that's really the next step. After you close the chamber, the machine will automatically get the plasma started. There it is, the plasma got started. Of course, you need the right amount of gases, pressure, and other conditions to get the plasma started. Once the plasma turns on, next step is to get the right temperature. The diamond will start growing, or a good crystal will grow only at the right temperature. So the operator really just needs to adjust the temperature, of course, measure the temperature using a pyrometer. That is showing what the setup looks like once you've got the right temperature on the crystals. The machine has several viewports on top and sides to see how the crystals are growing. And here's a video showing what the crystals look like once the right temperature is reached. Once you have the right temperature, just start the right process gases. Let the computer take over and run the process over several hours, probably several weeks, to grow the crystals. And all you do in this time is really just supervise the system, making sure all the parameters are running good, nothing unusual is happening in the reactor. But other than that, of course, the computer takes over, and pretty much the whole process goes automated. So over the next several days, all you're doing is supervising. And in the next video, we'll see a typical growth cycle as recorded over several days, but put in a few seconds. You can see 9 crystals just growing. I think this is about 150 hours shown in about 30 seconds. Once the crystals are done growing, next step is taking the polycrystals off using a laser machine, taking the seed off if required, and just cut the crystal out of it. Most of the time, we end up slicing the crystals grown over here to be reused further for experimentation, and that's what will show this particular growth after it was sliced. That's the growth from the chamber, and once the seed is removed, you can see the actual color of the growth crystal. And those crystals, once they're sliced, they can be reused as seeds, and that's what we do over here. This is another growth process showing 16 crystals uh, fused together. That's the laser system to take the polycrystals off and get the core, which can be used for cutting and polishing a diamond or slicing them into more seeds for further use. That's the view of our other systems. Irradiation and HPHT required for coloration and decoloration of crystals. Sometimes the crystals grown, depending on the recipe, can come out brown in color. And to remove the color, you have to run it through HPHT process for decoloration. That's as grown crystals, slightly brown, and once run through the HPHT process, turn white. That's the irradiation system. If you are looking to get the diamonds colored to fancy colors like blue, green, or pink, red, and others. That's about it from here. All right, back to you, Dusan.
Oh, of course. Thank you, Ashit. This was really very impressive. And right now I have to say that our guests can go to Q&A and write their question that will be or answered after the presentation. But right now I have a question for you. We know each other for more than 10 years. And if I'm not mistaken, you started in 2010 with irradiation or coloring of the diamonds with your electron beam. In 2013, you started with a new service of HPHT annealing after purchasing HPHT press. And finally, in 2015, you developed a CVD reactor for diamond growth. Except element 6, I do not know anyone in the world who has all these three crucial technology under one roof. And right now, my question for you is, what is your next project, if any left?
Dusan. So a significant part of our business is these days coming from universities, research labs, defense labs, for application in quantum physics, sensors, quantum computing, and it's really nice to be a part of those research projects. And beyond the reactor itself, I guess my next project will be to get more involved in the quantum physics side of application of these CVD grown diamonds. That will be an interesting thing to get into.
Okay, thank you. Good luck, and I'm sure that you will succeed, as everyone else, So, right now, we have our second panelist. This is Darshan Shah from Mumbai, manager and partner of DM Gems Group, which was founded by his father, Shashikant Shah, the man with the inspiring business biography, who is now chairman of Lab-Grown Diamond and Jewelry Promotion Council of India. He is unfortunately not with us today because of traveling, but Darshan will tell us much more about their business. Polishing factory, specialized in the lab-grown diamond processing. Darshan, welcome, and you can start.
Thank you, Dusan. Hello everyone, my name is Darshan Shah from DM Gems Group, and before we start I would like to thank Dusan Simic for giving us this opportunity of showing the process of cutting and polishing of lab-grown diamonds. Well, as you may know, cutting and polishing of diamonds is same as mined diamonds coming over the years, still traditional, but there have been really good improvements with the technology being used and the process which is much faster than before. So, well, as we know that we are giving this presentation or video on cutting and polishing lab-grown diamonds. Diamonds, as you know, CVDs, they come in cubic form and they still go through poly removal. But if you see the stone, you still can see there's a lot of poly around. Well, after even the poly removal is done, the stone goes through planing, then after planing it goes through laser curving, then again planing, blocking and then final polishing. So this stuff has to go through planing first. I'll show you the planing part. Come with me. As you can see, once the poly removal is done with laser curving, the stone is mapped and planned. You can see here the way it is paid for planning, and the multiple offcuts and the main stone coming out of this particular rough. This is how it is planned. From here, after planning is confirmed, it goes for laser curving. Once the stone is planned and marked, you can see the marking line going through. It is set on a setup station for laser curving to remove the extra areas and to remove the inclusions. Now let's go for the laser curving part. Once the stone is set into a die, it goes to the laser machine where again it is set with the point to start and the point to end in a laser. Once that is set, it is curved. It takes around approximately 15 to 20 minutes to curve one single side. Once the stone is set and curved and the extra area has been removed, this is how it looks. Once the stone is curved, you can see all the extra areas have been removed from here. There are still a few extra areas which are then processed on a diamond scale. You can see after removing everything, the stone has been planned for a carat approximate weight. Now let's go for the blocking process. As you saw, as the laser curving is done, now we have to go through the blocking process. This is how we block. We still use the traditional tops to block it, as it is handy and easier to block the stones. After blocking, which is half blocked, it goes to bruting. As you may see in here, the stone with the diameter is set and it starts bruting. Well, the traditional way has gone now, but the way the machine works and the basics of the machine to work are still traditional. Once the stone is bruted, it is again sent for scanning to see the maximum still yieldable stone from the blocked material and bruted material. This is how the final result would be, and then it goes for final polishing. In final polishing, this is the latest tools that we use and the tops we use, wherein each and every parameter, every symmetry is taken care of, and all the facets are faceted in a very particular way to yield a triple excellent round cut stone.
Thank you, Darshan. It was really nice, informative. And of course, I would have so many questions, but we'll limit it to one only. And can you tell us what will be the next technological advancement in the lab-grown diamond processing and polishing?
Well, technological advancements, there are many that are to be implemented, but the only one thing that we know which is to come very soon, it's a whole set of equipment wherein you put a rough in the beginning and the polish comes out at the end. Now, how would that be implemented to lab-grown diamonds? It's a bit of a question for us, but yes, it is under process, and there are many improvements and many advancements that are to be coming in near future, and one of them is this.
Okay, I'm sure that we will do similar like this webinar when you are ready to show us this new system, you know. And thank you. And right now we will go to our third panelist. This is Shreyans Shah. Is founder and president of Flawless Allure Grow Diamonds from Mumbai, India. He is one of the pioneers of the lab-grown diamond business in India, having started the company in 2007. The company now has an integrated manufacturing facility to produce lab-grown polished diamonds and lab-grown diamond jewelry. I met Shreyans first in 2006 when he submitted a 1 carat plus yellow synthetic diamond of Russia origin to EGL USA lab in Mumbai for certification. And Shreyans, right now, please tell us what happened since then with our industry. Welcome.
Hey, Dushan. Thanks. Thanks, Branko. Hi, everybody. I'm sure everyone is safe and well. Before I start, I'd like to thank Ashit for the wonderful insight into how lab-grown diamonds are grown, and Darshan for the wonderful informative video regarding the processing of lab-grown diamonds. What we are going to talk today is about the evolution of the lab-grown diamonds in the last 20 years, how it was back then and what it is now. Being a part of the industry since its humble beginning, the team at Flawless Allure has had the opportunity to see it firsthand, and what an exciting industry journey it has been so far. So to make it easy to grasp, I have divided the period of the last 20 years into 3 phases, and they are the early days, which is the period between 2000 to 2013, the interim period, which is from 2014 to 2018, and finally the post announcement, which is 2018 till today. So coming to the first phase, that is the early days, it's the period when no one had actually heard anything about lab-grown diamonds. I came into in touch with lab-grown diamonds as a product during one of my early visits to China and Russia for my industrial diamond business. And we came across these larger roughs from Russia and China. And it intrigued me, and it took me onto a journey to see how this could be a wonderful introduction to the global market. So as you can see on the screen, in those days, most of the roughs were yellow-orange in color. They would be somewhere between 2-3 carats in size, up to maybe 6-7 carats, but only yellow and orange colors were available in the HPHT ones. And with the CVD ones, they were mostly in the initial research phase. There was no commercial production in those times for the white diamonds. And for the smaller stones, we had the HPHT grown orange and yellow colors in the smaller sizes. So what we'll see in the next slide is polish yellow and orange in the larger sizes and in the melees as well. So in those days, there was no ecosystem really. Basically, everything had to start from scratch. Each small aspect had to be dealt with. from importation through the customs, getting those processed because most of the factories, they did not want to process this because of whatever issues were there. So everything had to be dealt with in its own specific way. Over the years, we've developed the ecosystem to what it is today, piece by piece, process by process. I remember very clearly what Dushan said right now, that we came up with the first lab-grown diamond, polished diamond, and we took it to one of the well-known labs, and they refused to certify them because they did not have the facilities to do it. Finally, I came in touch with Dushan, and Dushan with his team, we developed the certificate, the stationery for the certificate, and that's how the first certificates came about from EGL through Dushan. Also, most of the roughs in those days came from Ukraine, Russia, Belgium, Belarus, China, and US. Now, the second period is the interim period, which is 2014 to 2018. This was, I think, the most challenging period for the industry, because it was in a very middle ground. I mean, people had not heard too much about it, but there was still some goods available, and most of the goods that were available now were the larger sized roughs from Russia, which were probably 1 carat to 8 carat in size. You had the very small sizes for the melees coming from China, which were probably 10 stones per carat to 40, 50 stones per carat. And you had the CVD roughs, which were coming from Singapore and the US. So as you can see on the screen, we had the roughs coming in different colors. The blues were there, the yellows, oranges were already there. We had the whites coming in, and the pinks also. So this was the initial beginning into the actual growth of the industry. This is also the time when the race between the HPHT and the CVD started. With the HPHT, you had thousands of presses available, which just needed to be retrofitted in order to grow the larger roughs versus the smaller powders that were traditionally grown on them. And you also had the CVD technology, where the machine, the installed capacity wasn't really there. They were started to grow now. So there was this race between which was a better technology. So I remember in one of my trips to China, one of the largest HPHT growers in China, the head of research, he came up to me and asked me, Shreyans, which is better, HPHT or CVD? And somehow he was skeptical about the HPHT growth process, and he thought that because of the so many installed capacity of the HPHT presses, it would be a very competitive business. So he was keenly thinking about investing in the CVD side of the technology, and started wanting to grow in CVD technology. And it took me I had to go to great lengths to convince him that he had thousands of presses in his backyard, and instead of going to CVD, HPHT is what he should be looking at in terms of growing and mass growth of lab-grown diamonds. And luckily, he did stick to it. And right now, he's one of the largest growers of HPHT-grown rough diamonds. As I said, most of the roughs in the CVD were the larger roughs in white color, pink color. And from HPHT, they were the smaller roughs. So now we had a scenario where the melees were there, the larger goods were there, and the only issue was having those intermediate sizes of 10 pointers to 50, 60 pointers, which was very difficult to grow using the CVD process. One of our earlier customers, one of the largest jewelry companies in Europe, when they came to us for the first time asking for how we could develop this into a business, we had to convince them that instead of going the traditional way of what's available, how to go about designing the jewelry, we should first see what we have available within the lab-grown space, and do a calculation of what needs to be developed in terms of product development based on what is available, instead of going the other way around, where we develop the product and then we tell the supplier that we want this and this. So initially they were very reluctant to do this. Even the marketing team, their marketing team was a little reluctant on doing it this way, because they were never accustomed to do it this way. Once we told them, okay, we showed them the limitations, that these particular sizes won't be available in the in large quantities. We will not be able to scale them up, and finally we convinced them. And so we started the reverse journey, that we first saw what was available in the market. Based on those goods, they developed the designs and the products around those available goods, and that's how they introduced. And they introduced their jewelry range in the US market. A lot of resistance was there from multiple levels in those days, from the bourses, the wholesalers, the retailers, the jewelers. Everyone had their own apprehensions about this as a product. And also there was also the issue of disclosures, where certain bad apples in the industry, they started selling without proper disclosures, trying to mix into mine diamond parcels and all of those. A few of those companies, these had a short-term view of the market. They wanted to make a killing, a fast killing in the space. But however, fortunately, most of those guys are no more in the industry, because their business was not based on ethics, and karma has a way of getting back at them. So now what we see is there is predominantly disclosures across the board at every level, be it growing, be it processing, be it wholesale, retail, or online sales. Everywhere we see proper disclosures happening everywhere. Finally, we move on to the post-announcement stage. So what's all this about post-announcement? So what the way I describe it is, one fine day in May 2018, De Beers announced a Lightbox, a laboratory-grown diamond jewelry brand, which was to be introduced by them in the latter months. This was right before, I think, Vegas of 2018, and I think it was a fantastic announcement. They said it was going to be a fashion jewelry brand, and I think this announcement, in my view, has hastened the growth of the industry by at least 2 to 3 years. With this, I think everyone, even the larger players in the mine diamond industry, who were earlier apprehensive about entering the lab-grown space, were now looking forward to getting a pie into the cut in the pie. Also, with this announcement, a lot of big companies, they had announced their plans to enter the industry. The HPA versus CVD war, if we may call it a war, started in this phase, whereas the HPHT guys thought they are going to rule, and the CVD, on the other hand, thought they were going to rule the space. The way I see it is, it's not really a war. It's both are complementary products, because each has its own advantage. The HPHT technology has an advantage in terms of getting the larger goods, in terms of up to 20 carat, 25, 30 carat roughs are now being grown in the HPHT process. You also have the better colors. So DEFs are predominantly now being grown with the HPHT process. We also have the smaller goods. So exactly opposite side of the spectrum, we have the smaller goods also coming in from the HPHT presses. And above all else is the sheer number of presses that are already installed, which can give the kind of quantum which is required for this industry to grow at breakneck speed. On the other hand, we have CVD, which predominantly you have the lower colors, E, F, G, H, I, J, K, all the way to the light yellows and light browns, tinged goods. All of those comes from the CVD. Using the CVD process, we would not be able to grow the smaller roughs, primarily for the melees. So I think it's more of complementary. They both complement each other. So I don't think there's a war out there between these two. If played well, these both can be a fantastic amalgamation for the industry to grow. So a lot of these brands, online portals came up: Brilliant Earth, James Allen, Virtual Diamond Boutique. These came into the market in this flurry of event. Also, there were jewelry brands: Diama by Swarovski, Evolve, ADA Diamonds. All of these jewelry brands also got launched, and most of these companies are doing a fantastic, phenomenal job in growing the industry. A lot of the new mine diamond companies who came in are still thinking that it would be no different than what they have been doing for the last 2-3 generations. I think this is something which is they are underestimating the entire the industry and what it means. I think they'll be pleasantly surprised that to know that it's a completely different business with its own set of challenges, its own set of learning curve. Traditionally, the mine diamond industry has grown over years by oversupply and pushing goods in the value chain. Whereas with lab-grown diamonds, I think the most challenging part is how to expand the demand. Once the demand has expanded, it is easier to expand the supply. So unless demand is expanded, if the supply is expanded, I think that won't be advantageous to the industry, and industry will go the same route that the mine diamond industry has gone for the last 10-15 years. Also, the writing on the wall is very clear. It's a different business, and one will have to think differently in order to grow in this industry. It's not a sprint race, it's a marathon run. And patience, perseverance, and passion is what will be the differentiator from one company which has success versus another company which is a failure. Thank you, Dushan.
Thank you, Shreyans. Really, you remind me really about everything what happened in this 15 years that we know each other, you know. And I have a question for you also, just to start our Q&A, and our guests also have a chance to ask. But my question will be, I know that you are all around the world looking for the lab-grown diamonds, for rough, right? And please try to estimate and tell us, what is the global yearly production of lab-grown diamonds in rough, in carats? And also, what is the ratio between CVD and HPHT grown diamonds in production? I know that question is not easy at all, but I have also a second question. This is a simple one. How big is demand for color, lab-grown, and which color is most desirable? Please tell us.
Okay, so Dushan, I'll start with the easier question first. In terms of fancy colors, I think the pink and the blues are the most sought out colors in the market, because there's more visibility of those two colors in the mine diamond space as well. So carrying forward from that, even in the lab-grown diamonds, the pinks and the blues are the most demanded for colors. In terms of between HPHT and CVD, I think it's a 25-30% of CVD versus 75-80% of HPHT is the ratio that I'm seeing right now. The most difficult question to answer for anybody today is what is the actual production number in terms of carats per year. Even though what I can, instead of answering that question, I would rather say, what is the installed capacity for lab-grown diamonds today? I think it's somewhere between 120 million carats a year in terms of the total capacity, installed capacity for lab-grown diamonds. 25-30% would be CVD versus 70-75% of HPHT. This includes the lower end of the stuff, which is part of the growth process. It's not just gem quality. There will also be the lower quality stuff which grows with it. So I think 10 million carats a month is what I'm seeing as a decent number of installed capacity as of today.
Okay, thank you. Very good. And right now, Branko, you will take.
Thank you, Ashit. Thank you, Darshan and Shreyans, for very, very interesting presentations. I think we cover a whole chain from manufacturing diamonds, making them, from cutting them in the factory and selling them. So I think this is a unique webinar. So a lot of questions on this topic. I will start with more production of CVD. This is how questions coming. So maybe Ashit can help us with these first two questions. Why do you grow CVD diamonds and not HPHT, Ashit? I mean, obviously you do HPHT press for post-treatment, but you are focusing on growing diamonds by CVD. And what reactors you're using? It's an obvious question, but Anastasia asking from Russia.
Well, to answer this question, it really depends on where you are. We being in the United States, CVD is an obvious choice for lower manpower requirement, lot smaller machines, lot less maintenance required, and that's the field I am in. HPHT, requires the equipment's a lot bigger, mechanical, more maintenance is required. So yeah, that's really the reason for being in CVD business, which is the equipment is, I would say, a little more sophisticated in terms of operation. The next question, what reactor we use? I mean, we build our reactors over here, so we are in the business of selling reactors. To answer the question.
Okay. Another question, this direction for you, anonymous. How many cells how many diamonds you can grow at one time? It was one picture showing a few, but what is the maximum, I guess? And what is the rate of growth? Can you grow corollas as grown, or in this direction, how many of your diamond CVD are post-treated? How of them are as grown without enhancements post-treatment?
Yeah, if this is a generic question, then that totally depends on the reactor and the recipe you're running. If it's specific to reactors we make, then our recent 10 kilowatt reactors can do 50 crystals at a time. You can choose whether to grow as grown or HPHT process. Each one has its pros and cons. With HPHT process growth, the growth is faster, lot less inclusions and polycrystals as compared to as grown. But both the processes are definitely possible, and at the end, the operator decides what recipe to run.
Okay, thank you, Shit. Another question more for cutting these kind of diamonds, and we saw how very interesting to see how they're cut. Most people never seen how to cut natural or lab-grown diamonds. So for Darshan, are CVD diamonds softer or different to cut the natural diamonds? Can you, as a cutter, your people who are cutting it, just by cutting it, see by way how it cuts, this is a not natural diamond, it's CVD, or you cannot see a difference? Of course, you see different in shape, but can you see it by just a way how it's cutted? Are they softer or not? What is the answer?
Well, softer or harder or tougher, it's totally different question, because depends on the kind of rough you're working on. If it is HPHT, it's CVD, it's mine diamond. Again, mine diamonds, if it is a makeable rough or soluble roughs or a carps rough, it totally depends on the structure of the diamond. But end of the day, once the basic planning and blocking is done, all the poly, all the extra areas are removed, it is all the same. It is nothing major change from a mine diamond to a lab-grown diamond, be it the HPHT or CVD. Softer or harder, faster or slower? Yes, HPHTs are a bit softer, but at times, because of the crystal structure of CVDs, they are much softer. But it really depends on the environment and the kind of process that has been carried out to grow the diamond. So maybe that is the reason. But yes, it is as same as mine diamond. There is no change.
May I ask just something to add? For example, can you tell us, for example, during the polishing, or blocking, and depends on the pressure, the temperature of the diamonds on the wheel will be higher or lower. So with which natural or lab-grown diamonds you can go with a higher temperature?
Well, very frankly, when you're polishing a diamond or cutting a diamond, it is not on the temperature or the pressure that you're putting on a diamond to cut or polish. It is the RPM level of your scale that you're maintaining. Well, in the older days, it used to be 1400, 1800 RPM levels, and today it is 3200, 4000 RPMs. So pressure, I would rather say it is when the scale rotates, it rotates in the clockwise direction. So when a stone in a particular direction does not polish, you only change the angle of your dop so that it goes in the scale is in the clockwise direction, but your pressure is on the anti-clockwise direction. So that reduces the time to polish. So depends, there's no particular stone which goes in a particular direction. Once it touches the scale, then you decide what direction to take, what angle to take. So it is all the same. There is no pressure or temperature given to it. It is just the RPM levels and the way you feel comfortable to polish a particular diamond.
Mm-hmm. And what is the temperature that usually diamond show on the wheel? Natural or?
Well, no one has recorded this because we never.
It is not relevant. Huh?
It was not relevant. The only thing that we see while doing it, the polishing, it should not get too red. The moment it gets too red, the chances the polishing lines and it burns the diamond. It is not. It's like holding a paper and lighting it, but not burning it. You get a black layer, a carbon layer. In the same way, the diamond gets red. It is not burning. The friction is so much that it creates a redness on the diamond, which is not good. So we avoid that. I don't know what temperature it is at, but yes, we avoid that.
Okay, thanks.
So the art of diamond cutting is more to find the right direction of cut, and that comes with experience. So once that right direction is found, it becomes a piece of cake for the polisher to go about doing his job.
Yes. We call it in gemology directional hardness, and this is typical for diamonds. Has one direction, harder and softer. Natural, I guess, is different story in lab grown, but it's a art of cutting. One question you can stay with us, Shreyans, about, of course, most people in this trade and our attendee from 4 continents are appraisers, gemologists, traders, retailers. What is the value of laboratory grown diamonds? How compared to natural? How much you're selling them for? I know in my laboratory we do a lot of appraising since last year. It was mostly between 1 and 2 carats. Now I see more between 2 and 3, mostly CVD grown. A lot of mela HPHT and occasionally blues. I know it's difficult to appraise blues and other colors, but let's talk about colorless for a second. This is most common or most important.
Yeah, so the colorless pricing right now is dependent on the RapNet pricing, where because the mined diamond has adopted a system for its appraisal. The same thing is being adopted for lab-grown diamonds because end of the day, the entire value chain of the industry is following the same principle. So looking at that, if we were to compare on the street, we are looking at a 30% value of a mined diamond. So if a mined diamond is $100, this would be $30. So 30% would be on the street pricing for lab-grown diamonds versus the mined diamonds.
Okay, very good. We'll come back to you later. Just now, one more question from Adeline. She's running the nice gem lab in Austria. How long does it take to grow 1 carat CVD diamond? Just if you can tell us in matter of hours or days, maybe, for a sheet.
Yeah, so again, it totally depends on recipe, number of crystals you're growing, power, pressure, but typically a 1 carat diamond, if you talk in terms of polish, you're looking at 4 millimeter growth. it will take anywhere from a couple of weeks to a month, depending on the recipe you're using and number of crystals you're growing.
I see. Okay, I think this is a next question. I think could be Dashan, could be Shreyans, could be anybody, but it's a question of from me coming a lot of press release lately about laboratory grading and identifying if lab-grown diamond is as grown, is mean without post-treatments and treated. Do you see, I mean, when you're making them, when you're selling them, when you're cutting them, do you see a difference in price? If somebody asks you specifically, I want not treated lab-grown diamonds, and should be the price difference between these two categories? I mean, we can separate them as a gemologist. It's not easy, but we have instruments. Dusan has easier method. It's possible to do scientifically. What is, in your opinion, should be this category separated or not?
In terms of disclosures, yes, because the customer has the right to know if a diamond has gone through post-growth treatment or not. But on the street, when we come across customers, I have not come across a single customer in the last few years who has come specifically asking for an as-grown diamond versus a post-growth treatment diamond. Most people are not aware. So even those who are aware, they know that this is a normal production process of a lab-grown diamond, where they are grown in a lower color. And then you have a post-growth treatment, which enhances the color or which perfects the color. So I think it's more to do with the production process rather than anything else. It's not that you are enhancing artificially the price of the diamond. The production process itself is that you grow a lower color diamond first, you pass it through a post-grown process, and you improve the color, and that's how you go into the market. So I don't think the customers really care. As long as it's a beautiful diamond, well cut, has a fantastic brilliance, I don't think they have a problem with a post-growth treatment versus an as-grown diamond. That's been my experience. I think Darshan or Ashit can also chip in with their experience.
I agree totally with Shreyan's guy, because that is one of the differences between mine diamonds and lab grown or CVD diamonds, because mine diamonds, it is something, why mine diamonds or natural diamonds are called natural and these diamonds are called lab grown or whatever name that we use in future, I do not know, is because mining and cutting as per traditional trade are two different segments. Here in lab-grown diamonds, we see growing and cutting as one segment, trading as second segment, and retailing as third segment. So as far growing and cutting is concerned, it is one thing. Today, we may be working for many growers, we may be buying from many growers, but still, as a cutters and polishers of lab-grown diamonds, we come under the same umbrella of growers, because from us they get to know the stones were as grown or will they be requiring HPHT treatment. When the stones are, the moment the stones are grown, this is my experience that we have been dealing with many companies, you never know the perfect color of the stone. Even though you go and see it is, you say, yes, it is G color, as grown, maybe their chances will turn out to be I color, J color once it is blocked, and will require post-treatment. And this treatment is not to enhance the pricing. This treatment is to make sure that whatever the way it was grown, when it comes to the market, it is one of the best products a grower would put in the market. And this thing, as we have been, and personally, I have been saying CVDs growing and selling as roughs and buying them as roughs, it's a gamble. And HPHT and doing HPHT of these stones is again a gamble. You're not sure that the stone that you're saying a J color grown, HPHT, whatever process that you're doing on the stone to enhance its color, you're never sure that stone is going to come out as G color or H color, or will it turn purely black or chocolate or oilish. So it is up till the stone is perfectly polished and certified, the whole game is a gamble. Yeah,
Okay.
you know the process that you're growing, the way you're growing.
So very important point
Yeah.
Darshan raised was that once the post growth treatment is done, there's no guarantee at any level that it's going to enhance in color. We have seen instances so many times, more than at least 20-30%, where the stone has actually degraded in color. It's developed some clouds inside. It's gone from a nice GH color to a JKL color. So it's not the post growth treatment. That's the bottom line. The post growth treatment is not to enhance the value. It's to enhance the product itself, and it's part of the growth process. And it's not something besides that. That's how we see it.
I think it's very important that all of you are explaining this, because many people who are against lab-grown diamonds, or even gemologists, they think it's very simple. You just dial their some magic button. I want E color VS2, and then comes out. But Ashit, you know, it's basically a big risk for you when you start to grow diamonds, and you have to decide at the end, should you post-treat it or not? What is the bigger value? What is the risk of breaking it? And all these things, because HPHT press, we know, Dushan and me, these many experiments could break your diamond, because it's high pressure, over 50 bars and 2000 degrees, you know. So Ashit.
Yes, you know, one thing to keep in mind is this is a technology business. You're not mining where you're not sure what you're pulling out of the ground. This is a technology business. As time progresses, as we grow more, we learn more about these crystals. And I can tell you from scientific perspective, there's every way to control the process and get the best results you want. Is it practically possible? Yes and no. I mean, the difference between a D color and a HI color is very subtle. The control needs to be very precise. And we're talking about controlling 50 crystals or even 200 crystals in one production. So, you know, it's not like you're just growing one crystal and controlling its temperature and other parameters to get the best results. You're actually running 50 crystals in an environment where the temperature is pretty high, and a difference of 5% temperature difference could make a difference between EF color and HI color. So as time progresses, as growers gain more experience running the process, it's naturally going to get better. You know, crystals are going to get bigger, better clarity, better color. It's just a matter of making a progress over here.
I remember, you know, in the year 2005, 2006, Brandt from Apollo was in India. Yeah, if I'm not wrong, it was the same time, Shans bhai. It was 2005, 2006 time frame after Genesis came in.
2005.
Yeah, so Brandt was in India, and he had the product in his hand. And yes, we were in correspondence with them. So Brandt was in Pune. At that time we were in Pune. We were working from Pune. So we have seen browns which cannot turn white to browns which can turn to Ds. So if someone comes and asks me, I was too young that time. I used to just listen, and today I remember those things. Coming from 2003, well, 2000 was the mark when first Genesis came out with the production of commercial grown diamonds. 2003, they started marketing. From 2003 till date, we have seen 1,000 folds of a technology evolving, and it is evolving day by day. And someone says and comes and says that a grown color and processed or a post-treated diamond. Well, treating a particular diamond is again an art. Not all diamonds can turn to be good whites. Not all diamonds will be vivid pinks. Not all diamonds will be vivid blues. It is still a gamble. It is still a gamble. I know if I am not wrong, Ashit can say us this. When they're irradiating gray colored stone for pinks, it is not always uniform. You know, you come from baby pinks to pinks which are just fancy pinks, nothing else. They're not vivid, they're not intense.
Yeah, it's very
also,
true.
it is
It's too much of gamble. It is too much of gamble here.
Darshan, it's very true what you say, but as I said, part of my clientele is also universities and other research labs who are using, working on quantum physics application of these crystals. And it's very different working with them, right? Working with them, let's say we do irradiation for them, HPHT, or even CVD growth for them. They come up with very specific parameters. Okay, this is the kind of and more like numbers. When I work with diamond industry, they come to me and they say, "Oh, I want vivid pink. I want this pink. I want that pink." Versus when I'm working with universities over here, they say, "We want a flux of 10 to the power 17 electrons per square centimeter."
Right.
So
Right.
my life becomes a lot more easier working with universities where they know precise number and not not looking for me to get them a specific result visually. Of course, they do iterations. They get a sample, they get it irradiated, then they study the results, and then they pinpoint to a specific dose required for the treatment. So when I work with them, they're doing it more structured, more scientific, and eventually I can see they end up with a much better control on the process. And for sure, the same thing can be implemented for diamond industry as well. And the technology can be perfected. It's a matter of interest. So I work with a lot of traders, and a lot of traders are looking for a black box, press a button, grow a diamond. It's very interesting for us, and I'm actually working. I spend a lot of time trying to create a black box where we can predictably produce crystals out of these machines, and it's definitely possible. But at the same time, a grower can also, when they're working with a system, can develop their own processes and kind of pinpoint the process and come up with a predictable, repeatable process. Again, repeating myself, it's just a matter of time and resources. More resources people put into it, more time people put into it, more perfection will be produced.
Yeah, thank you. Like
I have to add something about the HPHT. First, I know all of the technology most probably will be in some far future routine, but right now it is not routine, and you have to think all the time. There is not the magic buttons. About the HPHT. When people are talking, they are saying just the HPHT, and they understand okay, this is what it means, HPHT treatment. HPHT treatment is a range of possibilities. And first of all, you have to know what you want to treat. And right now, I have a question from the industry, from the people there looking. They came to this, that they first have to know what is inside. What is a diamond? So it means they start. What is only one way that we know, that you need to have additional investment. They are instruments, and these instruments are not black boxes, something cheap, they're complicated stuff that give you a chance to really know what you have inside. Based on this, you will adjust depends what you have, what press and the possibility and the technology you have, you will adjust this to these results. And then you can say, okay, I expect to get the best color product.
Yes, I agree. And we have 2 more questions. They keep coming. But I just want to, in this direction that Dusan was talking, how is necessary for you who are making diamonds to know internal characteristic of diamonds. And we as a researcher, we're doing this for the last 20 years, 25, me and Dusan, studying the diamond in and out with different techniques. And I just want to mention upcoming webinar on February 25th. It's about that, how we're explaining in simple terms for everybody, as simple as possible, about advanced gemological equipment by John Chapman from Geometrics Australia, who is using some of them, and also is a physicist. So in this direction, Dusan, we have one question that both of us can answer. Why all CVD diamonds show only 737 nanometer line? I can answer that, and you can answer that one. How to separate in this direction that you're talking HPHT treated and as grown lab grown diamonds. So I can say that not all CVD diamonds are showing that line. Some of them don't, but most of them do, and they're showing additional lines. And this is exactly what we'll talk about in the next webinar and the upcoming book that is diamonds natural treated laboratory grown, that will be released this summer. But Dusan, how you can in our book you put these nice pictures on page 145 about cross polarized filters and 9 stones that are under cross polarized filter. This is your way, shortcut, very fast way to screen these diamonds, correct?
Yeah, sure. Just give me, because I used to have a chance to work with the different instruments, you know, and in some instrument that when you invest like, I don't know, $5,000 to $10,000, you will not see 737. But if you invest like $200,000, you will see 737. Depends on the size of this damage, and depends also of the instrument that you are using to find defects, you know. Right now we are talking about the really simple technique, you know, that it is complementary technique, you know, and of course, and Branko and me all the time we are talking, you know, this is our basic rule, at least two methods you have to use to make some decision. For example, this technique, cross-polarized filters, is complementary with the microscope. Of course, every stone goes first under the microscope. After that, this is a simple attachment. Polarizing filters will give you a lot of information, will give you indication, you know. And in the most of the cases, if you have experience, if you are working with this a lot, you will say, of course, this stone is HPHT treated. And in our book, there is explained, and this is a fairly simple thing, you know. And yeah, that's it. This is it takes like 2 seconds, you know, to say this one is as grown, this one is HPHT treated under in microscope under cross-polarized filters.
And we'll talk about this from April to June about the other, not only my and Dusan views. We like to host people to give a platform to talk about their views. We're good gemologists, but we're not the only one in the world who are good in diamonds. So we host different people. You will see later. But we also would like to host more trade people like you are, real people like, who are selling diamonds, making diamonds. So next March 4th webinar will be one that hopefully you'll join us at least as attendees and ask questions. Future laboratory grown diamonds, and Rob Bates from Jessica Magazine will host it. We're still finalizing the last panelist because it's would like to bring the biggest one, most important. And usually this is kind of very wide panel. And then on March 18, this is very interesting, and I have one question for everybody regarding this topic because you are here now. It's SCS Global Services actually doing a very interesting project. Now it's open for input, and if you're interested, I can send you a link to this website about sustainable diamonds. And basically this is interesting now for you who are growing diamonds. Not only they want to track natural diamonds, what is done in the past with different processes. Now they're asking major producer laboratory grown diamonds, including for example Washington Diamonds or other companies like I don't know, Shreyans, are you involved or not, but asking how to track diamonds from the factory to cutting process to the final consumer. This is a March 18. In this direction, we have a question from our attendees about environment impact of growing diamonds and compared to natural. Your opinion, just please short because we have to close in 5 minutes. 10, what is your opinion about because you are selling these diamonds, making these diamonds? I see very clean technology in your factory in New Jersey, but maybe it's a different story in India and China. What is your experience? What is your opinion?
When you talk about which one is more environmental friendly, it depends on what yardstick you use. So is the yardstick starting from the mining and the way the earth is disturbed, and the next stage of that disturbance is, are they being replaced properly? Are you doing all it takes to set it right again? To the cutting and processing and the retail side of it. In terms of mined as well as lab-grown diamonds, the remaining two processes, that is the cutting and polishing and the marketing, is more or less the same. So it doesn't change much. In terms of the growing part and the mining part, the normal, I think, number is that for every ton of ore, you get 1 carat of diamond rough. So that's the kind of disturbance to the environment is happening when it comes to mining. Versus, I think, whatever, if it's HPHT is a bit more energy requiring process versus CVD, which is less energy requiring. And if you grow if you create this energy using renewable sources, then the impact is even lower. So it all depends, end of the day, which yardstick you are using to compare these. But from a very logical perspective, if you see, mining definitely is more environmentally harmful to a lab-grown diamond. That's what we believe. And I think if some study is done, in-depth study is done in those regards, I think it will be proven one fine day that this is how it is.
Ashit and Darshan agree.
Yep. I mean, think of CVD grown diamonds. Yes, your major ingredient is hydrogen, but hydrogen is produced from water. I mean, we're using hydrogen generators to produce hydrogen from distilled water. The consumption of gas has been optimized now, and so has the energy requirement is getting optimized every day. So growing diamonds is in a reactor is getting more and more efficient. From growing 2 to 4 diamonds in a reactor, we are up to growing 50 crystals in a similar reactor with very little increase in power. So definitely there's a big change. And personally, I can tell you, I pay electricity bills over here, so I can tell you they don't hurt me too much.
Okay, thank you for your input, and we'll talk more about this end of March, and hopefully press will follow up as well, because this is topic everybody is interested. And just to tell you about something for those who are more into research, more into structure of diamond, defects in diamonds, spectroscopy of diamonds. We will cover it in and out, not only lab-grown diamonds. We'll cover natural diamonds, a lot of untreated diamonds. I think Ashit, for you will be interesting book from different angles, from angle of people who are doing these treatments in Russia, and definitely you know a lot about this, but you're doing it in the US, from people who are studying it, like university professor Dr. Zaitsev or Collins in England, who is used to be the Beers consultant, to myself and Dusan and Thomas Henschwagen, the lab people who are testing these diamonds with different instruments, spectroscopy, how we can detect if they're natural or treated or synthetic, and how far we can go with the case studies. And this book will be hopefully finished by September, looking for sponsors and looking for to do the seminars as to be fee-based seminars, but first one will be free. And if you have anything else to add, to be great, but we're almost 1 hour and a half talking about this topic. I think we have a nice material for people to come back and listen on YouTube channel. And for those who didn't get the book, we have this book 5 off coupon that you can save a few dollars, and great reviews from different people. Antonat Metlens, Renan Newman, the best-selling gemology book authors. So I would like to thank all of you. Dusan, great moderation and great talks. If you have anything else to say at the end, please do it now, and we can say goodbye to you and goodbye to our attendees from around the world.
Yeah, thank you, everybody, and see you again. just follow us, We are trying to give more and more. Thank you.
Thank you, Branko. Thank you, Dusan.
Thank you, Dushan. Thank you, Branko.
Thank you.
Thank you,
Bye-bye.
thank you, everybody.
Thank you.
I
Bye.
think it was
Take care.
very interesting, and hope to see you in New Jersey or Mumbai one day.
Yep.
Sure.
Bye bye.
Bye.